My name's Miss Plant, and this is the first in my series of videos in which I'm going to go through the AQA Physics GCSE specification for you, so that you can make sure you've covered everything and that you can get the best possible grade you can. So we're starting with 4.1.1.1. Essentially 4 is the start of the content, where they list the content you need to know, and 4.1.1.1 represents energy stores and systems. That's where we're going to start. So the first thing about it is that we define systems in physics. So when we want to study a group of objects and how energies are transferred, we like to define a system. The system could be a single object, it could just be a tennis ball, or it could be a group of objects. So it could be the tennis ball and maybe planet Earth, maybe a couple of tennis balls that are going to collide with each other. Now, whenever the system, whatever we define, whenever the system changes, whatever we choose to be the system, the way that the energy stored in the system is also going to change. Now, there are 8 ways that energy can be stored, and 8 stores of energy that we define. This has changed a little bit, so you might have done different ones in Key Stage 3. These are the ones that we currently use. Now, there's a handy way of remembering them, a little mnemonic, right? Kilogram of cement, right? So a kg of cement, and then you can remember that. So there's kinetic energy stored in anything that's moving. As physicists, we like to be lazy. I don't like writing the word kinetic, so instead I'm going to write EK, energy kinetic. Gravitational potential energy, anything that could fall has this energy, EP. Chemical energy tends to be more GCSE chemistry, but we might look at chemical energy when we do kind of nuclear physics a little bit, I guess. Electrostatic energy, so positive and negative charges can have this kind of energy. So if you pull a positive and negative charge apart and hold them there, they will store that electrostatic energy because of their position in each other's electric fields. It's a whole topic that we'll do later on. Same for magnetic energy. North and south poles, same south poles. Any kind of magnets that are forced apart or forced together, they can store that magnetic energy, which will then kind of ping back if you let go, if you like. Elastic potential energy stored in springs, that's EE. So springs or anything that can be compressed or stretched. Again, we'll go through that again. Nuclear energy we'll do later on when we do fission and fusion. It's the energy stored inside a kind of nucleus that can be released under certain conditions. And finally, thermal energy. Anything that has a temperature, which is everything, has a store of thermal energy because the particles are moving. There's kinetic energy inside the particles, and that's thermal energy. Now, those are the 8 types of energy. There are 4 ways that energy can be transferred from one form to another. From heating, just changing the temperature, heating something up, putting something in something hot or cold. Electrically, so most commonly we'll transfer energy electrically to appliances to get them to change energy. Radiation, waves. So at the moment, as you're watching this, light waves going into your eyes, sound waves going into your ears, energy is being transferred via radiation to you. And then finally, mechanically. So if you kind of touch something or apply forces, then energy is going to be applied mechanically. And they make a word herm, which is kind of like an island off Jersey or Guernsey, I forget. Right, now there are 5 examples that AQA want you to know about in terms of energies can be transferred. They could ask you about anything, but these are kind of their example common situations. So an object projected up. Now, if I'm throwing this ball up, I'm transferring energy mechanically to the ball because I'll be applying a force to it. That will originally give the ball some kinetic energy, but as it moves up, that kinetic energy will quickly turn into gravitational potential energy. And then if it falls back down again, back into kinetic energy before hitting the ground, when energy might be transferred mechanically to thermal energy of the ground. Moving object hitting an obstacle. So if you've got an object that's moving, it's going to have kinetic energy. And if it hits an obstacle, most likely, I guess if it's like a squishy thing, it could cause some elastic potential energy in it, but most likely that's just going to be to thermal. A lot of these have energy wasted, which is be thermal energy dissipated to the surroundings. But again, that's another whole bit that we'll cover. An object accelerated by a constant force. Now, there's an equation for this, and the work done or the energy transferred is equal to the force times the displacement. That's an equation that, again, we'll look up, but that's how we can work out how much energy is transferred or how much work is done by forces. In general, if I'm pushing something, then it'll be chemical energy in my muscles, which will be transferred to kinetic energy. right? Mechanically, that will be a mechanical transfer, and my store of chemical energy will decrease, and whatever I'm moving, its kinetic energy will increase. A vehicle slowing down, well, this is how brakes work. The car has a lot of kinetic energy, and then as the vehicle stops, that kinetic energy source decreases, and the brake's thermal energy increases. So as the car slows down, it loses its kinetic energy, the store decreases, and the thermal energy store of the brakes increase, and brakes get really, really hot. Boiling water in a kettle, it allows us to look at work done when a current flows, energy transferred when a current flows. There's actually an equation. Energy transferred in a current is the current times the time times the potential difference. E is ITV. We'll look at that again when we do electricity, but that's just a way we can measure the energy transferred through electrically. And then that will be transferred to the heating element at the bottom of the kettle here. So the kettle has a heating element. So it's going to be thermal energy in the element. Now the element is in contact with the water in the kettle, so the thermal energy in the element, because there's a temperature difference, transfers and increases the temperature of the water, which increases the thermal energy in the water. So this one is not the most interesting one. Energy is transferred electrically to the kettle. It depends on how you made it as to what store it was in beforehand. It's then transferred to the thermal energy of the heating element. The thermal energy of the heating element then transfers to thermal energy in the water. There's another equation. The energy in the water is denoted Q, and that's the mass times the specific heat capacity times the temperature change of the water. But that's another question to look at. This topic just kind of like picks a little bit at some things that are hints and some things that are coming up. Okay, that's it. Good luck.